Two conducting spheres have a net charge of 5 millicoulombs and negative 9 millicoulombs and attract each other with a force of 4.05 times 10 to the third newtons. The spheres are brought into contact and then moved apart to the initial distance, which notice we don't tell you what it is. What is the new force between the spheres? Is the force attractive or positive? The answer will be B, but let's go to the next slide and see how we got it. We start, as always, with Coulomb's law. And then the first thing we have to do is find the distance between the two spheres if we want to find the force later on when the charges change. So we rearrange the equation to solve for the distance. Always do that first, don't just plug the numbers in. And then we have our K value, we have our two charges, and make sure millicoulombs is 10 to the minus 3. And the force is 4.05 times 10 to the third newtons. And the spheres are a distance of 10 meters apart. Okay, so that's the first part of the problem. What do we do next? We have to find the charge on each object, on each sphere. Well, our net charge in the beginning, which will have to be the net charge at the end due to conservation of charge, is 5 millicoulombs minus 9 millicoulombs, which is a negative 4 millicoulombs. What do we have to do next? We then split that in half. The charge is shared. So we divide Q net by 2, and each one now is negative 2 millicoulombs. Now, perhaps you can see why we solve for the distance over here. We go back to Coulomb's law. We have our new charges, and we take the magnitude of it because we're just trying to find the force. We put the numbers in here along with the distance we found, and we get 360 newtons. And why do we say it's repulsive? Because both charges are negative, and like charges repel.